On January 15, 2022, the uninhabited volcanic island Hunga Tonga-Hunga Ha'apai erupted violently, creating worldwide shockwaves, sonic booms, tsunamis, and powerful winds, all while blanketing surrounding islands in 2 centimeters of ash. It was a fatal eruption, and its impact on nearby communities was further compounded by the disruption caused to emergency services. NASA has been following the Pacific Islands' unusual evolution for years. Using historical observations and satellite data of the January eruption, scientists have shed a new light on why this explosion is so unique and how such a small island is making such a huge impact across the planet.
It gave us a window into a rapid-paced life history of an island that we can compare to hundreds of other islands in the oceans over time. And these islands are sensitive indicators for the activities of climate, environmental change, and we can project them forward even to other planets. So what an opportunity.
Geologic records suggest that while the volcano may have produced massive explosive eruptions in the past, an eruption of this magnitude wasn't expected so soon.
This was what we call a Volcanic Explosivity Index 6 eruption. Nothing like it since Krakatoa in the 19th century. And so what happened was this beautiful little island, 100 meters tall, growing, forming by the nature of the way volcanoes and water interact, was explosively changed forever. And literally the entire base of the volcano fell hundreds of meters into a shallow magma reservoir, a liquid rock chamber, literally under the ocean. And that allowed the explosive interaction of a massive Pacific Ocean seawater with this hot rock, 1300 degrees Kelvin. That's super hot, hotter than your oven. And that explosion with the pressure moved the water, the rock, the small amounts of ash that were part of building the island all the way into the atmosphere and triggered a large tsunami, a 15-meter high superwave that traveled out hundreds of miles, buried some local islands as part of the Tonga archipelago, but allowed us to see the power of Mother Nature's volcanoes when water and liquid rock come together to shape our planet.
NASA and ESA satellites clocked wind speeds up to 450 miles per hour, just hours after the eruption, and showed material rising up to 36 miles, the highest volcanic plume ever measured. Within 2 weeks, the main plume of volcanic material circled the entire globe, injecting dust particles into the stratosphere that remained for upwards of a year. NASA also found that the volcano injected a tremendous amount of water vapor into the Earth's stratosphere. The increase of water vapor, which traps heat, could modify atmospheric chemistry and have a warming effect on the Earth's surface. So outside of its sheer magnitude, what makes this eruption so unique? Well, it's really a matter of our ability to see it. At the end of 2021, the island's volcanic activity started picking up. Small underwater eruptions began to reshape the island's landscape, expanding the island. These shallow water events are classified as Surtsean eruptions, where hot magma interacts explosively with water. In other words, we've been able to see the birth of the island happen in ways we haven't been able to before. And with modern satellite technology, we're also able to see the end of the island's life cycle in new detail, as we did with the January eruption.
This has happened in Earth history, in famous places like Yellowstone, Taupo, New Zealand, Krakatoa, and now in the island nation of Tonga. And so we have an opportunity, 21st century techniques, laser altimeters like ISAT-2, satellite techniques that can see at scales of sub-meter, to put those together and tell a story of the birth and death of this island.
NASA's vantage point of Hunga Tonga-Hunga Ha'apai could even be used as a means to study other planets in our solar system, specifically the role that volcanic islands play in water planets like Mars and Venus.
We live on an ocean planet, and so these kind of eruptions are part of our history, how we got here as we evolved ourselves in the context of our planet. And we want to take the lessons that we learn as we go forward, as we continue to watch what's next in this exciting volcano, and apply it forward to other worlds, like Mars and Venus, that may have harbored surface waters as oceans or seas, and understand them in the context of our Earth.
Using geostationary satellites and observed data, NASA scientists hope to learn from the continuous evolution of this special volcano.
The question is, will those come again at Hunga Tonga and then explode again? We don't know. So we need to use what we saw from this eruption in 22 to train ourselves for what to be able to predict. And so this is our chance to learn and then to apply it to the other ocean worlds nearby that we really hunger to study.